C Sharp language syntax. The primary topic in C Sharp for anybody to start an entry into. See, like every other language, even C Sharp will have the basic things as common. It will have data types, casting, conversion from one type to the other type, string handling, working with for loop, while loop, basically control statements. It will also have operators, plus, minus, multiplication, division, and so on. And here also we are first going to learn how to work with arrays, how to write functions and call functions. So any programming language you take, the basic order, the sequence of topics in the beginning is going to be common. Even if I am teaching you something like Java or Python, this particular order would not change. So yes, there are two things we are going to now look at. One is the language by itself, and of course the concepts of the programming language in context of the C Sharp language. Most important thing, C hash is what we write, but we never pronounce it as C hash. We always have to write C sharp. We have to basically write C hash and read as C sharp. Now actually that sharp symbol has come from the musical keyboard. If you have ever got a chance to look at the musical language, one of the symbol in the musical language is the slightly tilted hash symbol, which basically represents high tone. So how it all came is C Sharp, C made musical. In other words, C made easy. That's how C Sharp actually got its name originally. But doesn't really matter. It is indeed a very simple programming language. And the beautiful features of strong typing, imperative, declarative programming practices, functional, basically we can write functions. We have a lot of generics, which are again a feature. It's a completely object-oriented programming language. And of course, now using C Sharp, we not only do small things, maybe as simple as building a simple console-based application. We can also use C Sharp for every other type of application development in .NET. Now that application can be a Windows-based application, GUI application.
Hey Sandeep, this is
So advanced applications also, like web applications, or going forward, it is now told that C Sharp can also be used for artificial intelligence application development within its own capabilities. Right now it doesn't have that feature, and some languages like Python have big edge on these things. But Microsoft is already working to make C Sharp also inclined or line up on the same lines for building really advanced level application. So very powerful language, a modern language, an object oriented language, and of course all coming from C family. So syntax of C Sharp will be very similar to that of C language syntax. At least in the beginning, you will see that very common syntax is what C Sharp has. So yes, it has evolved over a period of time. We already have 7.x version, 7.0 version to be precise. But over a period of time, we will see that we would have C Sharp 8.0 also. Very soon it is probably going to be launched. So right from year 2002, when C Sharp had 1.0 version, and now that is year 2018, we already have 7.0, expected 8.0. And of course, with every version, the features were added. This table is incomplete, and even then, otherwise it would not make much sense to you at this point of time, because you have to look at not C Sharp from 1.0 and then upgrade to 2.1.2 and then upgrade to 2.0. You don't have to do anything like that. even if you are learning C Sharp 8.0, remember that the basic features will still remain as it is. Nothing will change. Any feature which was introduced in 1.0 will guarantee be there as it is in 8.0 also. So what is the evolution? Things were made more and more simpler. They were providing alternatives of doing the same thing so that programmer efforts would go down drastically. That is where a beautiful feature called as LINQ was introduced in C Sharp 3.5. 3.5 actually gave LINQ, language integrated queries. So this was one of the beautiful feature which I believe has made the language much easier than it was before. Another feature which was very useful, which was introduced in .NET Framework 2.0 itself, was generics. Rather, very few people know it was only in 2.0 version the runtime of C Sharp language was changed. That means something which changed in runtime was only in .NET Framework 2.0. All subsequent enhancements are all at the compiler level. They did not make the change at the runtime level. That means only programming features changed. The outcome, we could have also done it in the previous version, but it was complicated. So that's what is something which you should know. It's kind of secret. The last major change which happened to C Sharp was only, not C Sharp I would say, last major change which was happened to CLR was only in .NET Framework 2.0, where generics were introduced. After that, it's all language change which has come. Doesn't really matter to us when we are beginning everything from scratch. So yes, the most common question which I ask anybody is, when I start teaching the language, we have to start with data types. There is no other entry point to the learning of language. Now, how much time does anybody want to take for data type? Okay, it's like this. You tell 5 minutes, you tell 15 minutes, you tell 30 minutes, you tell 1 hour. First, most important thing is, what is that a program is made up of? What is that an application is made up of? Application is always made up of instructions and data. Instructions are what processor executes, and through these instructions what flows is data. When I say data, it can be integer, it can be byte, it can be some floating type, it can be boolean type, it can be string type, or it can be any other type for that matter. And it is all this data only which is going to flow through the instructions, and it is this data which is going to reside in memory. So when there are only two aspects of learning, instructions and data, I'm not sure why we can finish it or how we can actually finish this topic data type in 5 minutes, 10 minutes, or even 1 hour for that matter. Yes, as some of you have presumed, it is a present continuous process. But initially itself, complete focus, even if I want to give on data type, it cannot be less than at least 2 to 3 hours continuous discussion on data type, because that's the primary element on which we are going to work with. That is the basic thing which we have to understand before even we start writing program, because a program is all about getting some input and producing some output. So unless we understand the data types properly, I'm pretty sure we cannot make our mindset to write proper instructions through which that data will flow, which should and must have some kind of type. So let's begin with that thought process that it's not a small topic of 5-10 minutes. It's going to be a quite lengthy topic. First and most important question to you is, why do we need data type? Yes, we need data, and for that data we need type, and that's what we call it as data type. For example, 10 is an integer. So integer here is a data type. And let's say my name is a string here. So string is a data type here. I may probably write something like true, or maybe sometimes I'll say false. This is Boolean type. Boolean is the data type over here. Like that, I can have different other types of data which is also possibly made up of combination of these types. Composite data types we can call it. Something like a structure if you know in C programming language. So we can have basic data type. We also call it as primitive data types. And we have got composite data types. Primitive data types are existing on their own, and composite data types will always be made up of other data types, which can again be a combination of primitive and other composite data types. But point is, everything is a type. Every data has a type. Now the data can be stored either in a variable. We can store data in some variable, or we can have it as a constant. For example, all these I would say are constants. Can we change the value of 10 to something else? Obviously not. Can we change the value of Sandeep to something else? No, Sandeep is Sandeep. It cannot be changed. True is true. It cannot be changed. False by itself will remain false. It cannot be. So these things are all constants. Constants cannot alone be sufficient for writing any kind of application. For writing application, we would guarantee need variables. Variable is something which is going to change. Obviously, the opposite of constant. Constant is fixed. Variable is variable. It will vary over a period of time. So what is a variable? Variable, I would say, is a name which is given to a memory location. To some memory location. So in memory, we have some location in which my data is going to reside. Actually speaking, memory is identified by its address. But programming with address is going to become low-level programming. So in high-level programming languages, we have the benefit of identifying a memory by its name, and that name we are calling it as variable. So the language requires now a variable where the variable data is going to be stored, and most important, every variable is supposed to have data type. Now why should a variable have data type? That becomes a question now. See, it is based on the data type. Yes, there is no doubt every variable is going to be allocated some amount of memory. It can be 2 bytes. It can be actually 1 byte. It can be 2 bytes. It can be 4 bytes. It's always in the factor of 2 power. That's how the languages actually allocate memory. So it can be 1 byte, it can be 2 bytes, it can be 4 bytes, it can be 8 bytes, it can be 16 bytes. All primitive data types will have any one of this number only. But that alone cannot be the reason why a data type should be associated with a variable. For example, if I take programming language C, I'm not even talking about C#. Let's say we have got a data type called as long. In C, long is 4 bytes and float is also 4 bytes. Long is 4 bytes, float is also 4 bytes. So can size alone be the criteria? No, it cannot be. So it cannot be like I want 4 bytes of memory, so I'll take long. Or I want 4 bytes of memory, I'll take float. Guarantee there is some difference between float and long. So I say the major reason why we have to choose an appropriate data type for every variable is, it is based on the data type only. The variable is going to be allocated X number of bytes, and the most important, the format of data in that memory location is going to be decided based on data type. So in these 4 bytes, how the value is going to be stored in binary system, that format will be decided by long or float. The format of long storage and the format of float storage is different. It's not the same. So it's the size and format both have to be considered when we want to associate a data type with a variable. 1. 2. Can I have a divided by 2? Obviously this is going to be a error, and for languages like C or C sharp, it is going to be a compilation error. A string cannot be divided by a number, and when I say string cannot be divided by a number, am I using data types here? Am I using rules based on data type here? Yes. Compiler, which is always responsible for checking syntax, is going to make use of data types of the variables to ensure that the variables are properly used in an expression. If the data types are there, compiler will use those data types to validate the expression. The operand and operator's relationship is correct or not. So that is the reason compiler is going to give error for these kind of things. Likewise, one more major thing because of data type we achieve is, what is the value of 5 by 2? Many will give answer as 2.5. But what happens is, most of the runtimes are going to give me value as 2 and not 2.5. Why? Because here 5 is of type integer, 2 is of type integer, and when 5 is divided by 2, we are again supposed to get integer only. We are not supposed to get floating type. So the result of this is 2 and not 2.5. So in other words, can I say runtime is going to decide the value of an expression based on the data type of operands involved in an expression. 5 and 2 here are the operands, and of course this is the operator. So 5 and 2 both being of type integer, the result is of type integer. Who said this? Runtime said this. So data types are not just used by the developer who is going to use that as a base for deciding the size and format, but also they are used by the language compiler and the runtime. Everywhere, in other words. And languages like C sharp are considered to be strongly tied programming languages. They give lots and lots of importance to the data type. And because of this only, the output, the compiled program which we are going to get is going to be very rigid, and it is not going to crash instantly. Lot of validations are going to happen then and there at the time of compilation. And of course, even runtime for that matter takes into consideration the data types when assigning values from one variable to the other variable, and we are going to see that practically. So yes, very important point. It is based on the data type, the size of the variable, and the format in memory is decided. It is based on the data type, compiler is going to validate the expression. It is based on the data type, runtime is going to evaluate the expression. Runtime evaluation of the expression is going to happen. And for these reasons, we have to learn data types as much in depth as possible. They are important. And most of the people are poor in programming because they don't understand data types also properly. For example, here are different data types of language C sharp. We call them as integral types. These are all integral types. Then we have got floating types, and then we have got other data types. There is also something called as fixed point. We'll discuss that. So all these together are referred as primitive data types. Remember, integral types, floating types, fixed point type, all other type. They're all together referred as primitive data types. Those are basic data types. Now, always remember the size here is in terms of bytes. most of the interview, when I ask people what is the size of integer, they will tell me 4 and then stuck. What is that 4? Is it 4 kilometers? Is it 4 liters? No, it is 4 bytes. And we all pretty well understand 4 bytes is into 8 bits, which is 32 bits. And for me, it is very easy to confuse anybody for between bits and bytes. I will ask them, how much is 1 byte equal to? How many bits? This is easy answer. Everybody should have studied in their graduation. Very easy answer. 1 byte is equal to 8 bits. But when I tell them, tell me what is 1 bit equal to how many byte? Here comes the basic mathematics. And people get stuck. Just 1 by 8. But this is where most of the beginners, most of the freshers are stuck. They only know byte equal to how many bits, but 1 bit is equal to how many bytes. They are stuck. No, don't get confused. We would always want to confuse you when we are taking your interview. And when we are asking you size, be precise. Byte is 1 byte. Integer is 4 bytes, not bits. And good thing you know, in .NET, the size of integer is fixed. Unlike in C language, on certain platforms it is 2 bytes, on certain platforms it is 4 bytes based on the type of operating system. It is here fixed. Always it is 4 bytes. And the next important thing here, .NET Common Type System. Remember, whenever we write our code in C#, we know that the C# language is going to compile itself into MSIL code. And what goes as input to CLR is MSIL code, which is further converted to machine code and executed. But if I look at from a C# point of view, my only target is MSIL code and nothing beyond. Beyond will be taken care by the runtime, .NET runtime. Likewise, if I write code in VB.NET, there also I am going to get as output MSIL code. If I write code in F#, there also I am going to get output in MSIL code format. That means any .NET programming language, when compiled, the output produced is MSIL code. And this MSIL code is common, whether it is here or here or here, it's all common, and that's why it is executed by CLR, Common Language Runtime, the name, Common Language Runtime. But the point here is, if I write something in C# and compile it, can I use that in VB.NET? Yes, absolutely. C# is language independent. Code written in one language .NET is language independent. Code written in one language can be easily interoperated in another language because of the intermediate layer MSIL. Why? What could be the major problem in interoperating code of one language in the other? Most of the time, the reason why we would not be able to interoperate code of one language in the other is because of the difference in the data type. So if I go back in the history, if I use some data type like, let us say, variant in VB, there is no equivalent of that in C language or C++ language. Or the way strings are handled in VB and C++ is absolutely different. So one language deals with the data type in one way and other language deals with similar data type in a different way. Their formats are different or their sizes are different. Is a big concern. So what .NET said is, hey, don't worry about data types in the language. I am going to take care of data types at runtime, and data types specification is provided for CLR. So actual data types of .NET are system.byte, system.sbyte. system.in16, system.uin16 and so on. These are the actual data types in .NET. These are the data types in MSIL code. But for the language simplicity, languages also have their data type, but remember those are nothing but aliases to these data types. So if I am declaring a variable in something like C# language, I am going to write, let us say, integer n. I can always write int 32, system.int32 n. Both are same, absolutely no difference between both of them. Why? Because on compilation, int is ultimately going to convert itself to int32 only. Likewise, if I talk about VB.NET, I'll say dim n as integer. And this also is eventually going to get converted into system.int32n. So whether it is C# or whether it is VB.NET, both of them do not provide meaning to integer. It is MSIL which provides meaning to integer. Hence, data types are independent of the language. And those data types which are there in the language are referred as common type system. They are all specification in CLR, that is common type system. So CLR gives specification, language does not give specification for the data types. That's the beauty here. But still you see data types in the language which are nothing but aliases. So one very important point, every data type you should know the size. For every data type of the language, you should know what is the corresponding .NET data type, common type system data type. The next important thing which I want you to consider is, it is based on the data type. Many times we will have a limit on minimum value and maximum value, especially for numbers. There is always a minimum value and a maximum value. So if I take byte, see, my intention is not to teach binary system here, but just to give you the startup. And if you really want to get into binary system, look at my C training videos. They have in detail covered everything. But right now I say 1 byte is equal to 8 bits. So in bits, I can put something like this, 8 bits. This is maximum value. Like that, can I say minimum value will be all zeros? This is minimum value. This is minimum, this is maximum. Now, here comes a small point to be noted. We have two data types, byte as byte. So basically this is unsigned and this is signed. Negative values are allowed here. Negative values are not allowed here. Then we have got short, U short. Short allows negative, U unsigned short does not allow negative. So that's how they are different. So now when I talk about this and when I talk about this, 8 bytes, remember the basic difference between signed and unsigned. In case of signed, the last bit is going to be a signed bit, whereas all other data bits will be the data bits. First bit will be the sign bit, the most significant bit would be the sign bit. Rest of them are all data bits in signed and unsigned. In unsigned, all are data bits, including this. All are data bits in unsigned. So in unsigned, if I take all as data bits and this, can I take it as 0 as the minimum value? Yes. But in case of this, and of course, what will be the maximum value? All ones will be the maximum value. I'm talking about all data bits, that is unsigned. All ones will be the maximum value. So when I say all ones, I have 2 power 0 2 power 0, 2 power, and it goes on like that. 2 into 0 plus 2 power, how to write this in notepad, it's problem. 2 power 0 into 1, 2 power 1 into 1, and it goes on, goes up to 2 power 7 into 1. This 1 is nothing but all 1 bits. 1, 1, 1, all this 1 are all 1 bits. Now, if I take sum of all these things, it's going to be 255, which is basically nothing but 2 power 8 minus 1. That's it. I can say this 255 is 2 power 8 minus 1. If you understand all this, well and good. If you do not, please refer to the binary system. Not necessary though. If you understand, good. If not, ignore it. In other simple words, I can say that if it is a unsigned number, minimum is 0, maximum is 255. Sorry, here, yeah. 2 power 8 minus 1. 0 to 2 power 8 minus 1. What is 8? 8 bits. And here if I take, how many data bits we have? We have only 7. And that's why it is minus 2 power 7 to 2 power 7 minus 1. Remember, 0 doesn't come under signed or unsigned. 0 is neutral. There is nothing like minus 0. Remember that. Never write minus 0. It has no meaning. It's 0. That's it. Minus 1 and plus 1 are different. But there is nothing like minus 0 plus 0. So 0 they put it under this category. That's why that minus 1 comes here. Other than that doesn't happen here. If I generalize it and say that integer is 4 bytes, which becomes 32 bits, the range of integer would be minus 2 power 31 to 2 power 31 minus 1. And of course, if it is signed, it is 0 to 2 power 32 minus 1. This you have to remember. At least for the sake of interview, you have to remember. But language gives you very simple solution. C# language, you can simply use integer dot min value, integer dot max value, and you will get the value. That's it. So I create a project in C#. Let me create a new one otherwise. I'll create a new project. Call it as C# console application for .NET framework. Let's say data types demo app. I want to store it in some folder. Click on OK. That creates a C# console based application. And I start writing my code here. I can say console.writeLine integer.max value. I can print console.writeLine integer.min value and put here, execute the program, and we get this. Fantastic. Now you can do that 2 power 31 minus 1. 2 power 31 minus 1 would be this, and 2 power 31 would be this. You can find out that for yourself. So with this example, we understand how the language is supporting us. Min value, max value, and so on. So yes, this is one aspect of data types which everybody should know. What is the minimum value? What is the maximum value? I will not ever expect you to give me this number. I'm not asking you to memorize 2147483647. No, I'm not asking you to memorize. When I ask you what is the range of integer in any interview, I expect you to give me in 2 power format. And this is applicable only for integral data types. This is not applicable for floating types. though it is 4 bytes integer and 4 bytes float, both are 4. The data in memory in context of floating point data type is not saved in as simple format as this. No, it is not in simple format like this. It is absolutely different format to represent dot. Why do we call them as floating type? Why do we call it as floating point? Simple. The position of dot is not fixed. It is a variable. It can come anytime in a value. After dot we can have actually 7 only, but we say 8. We can have maximum up to 7 digits. In float, after dot we can have 7 digits after, in a 7 digits we can have after the decimal. Whereas in double we can have maximum up to 15, but we write 16. That's okay. We can keep it as 8 only. Maximum up to, that is 8 and 16 digits are allowed after the decimal. So the position of dot is not fixed. Position of point is not fixed. That's why they are called as floating point. Remember this. So though the value of float is 4 bytes in size, remember, just for comparison, see the maximum value of float. E is nothing but, let's say, 10 power 38. 38 zeros you should think of. And double, you see, beautiful. 308. 38, 308. Easy to remember. See the range difference between float and double itself. In one case we can have up to 38 zeros. In the other case we can have up to 308 zeros. Huge difference. So when to choose float, when to choose double, use float most of the time. Only when you want to deal with extremely large values, then you should use double. The range of double is highest among all the data types. That's the maximum number which a computer can represent. Whatever value we can accommodate in double. Remember, float and double both have a problem. Now what is that problem? If I take, say, 10 by 3, we know that the value is 3.3333333, and it always goes on. We can say 3 bar. So the point here is 3.333333 into 3 is never equal to 10. We'll never get back 10. First 10 you divide by 3 and then multiply by 3, you will not get back 10. To be precise, 3.0. Otherwise it will become integer division. So 3.0 is double division. And result will be double. Multiply again with a number. Because this is already double, doesn't matter whether it is 3 or 3.0. You will never get back 10. You will not get this. Why? You know the answer. This is simple mathematics. But here we know that there is a data loss. So whenever we are dealing with float and double, there is data loss. Which one loses data more? Obviously, float will comparatively lose data when compared to double, because we know pretty well 3.3, and if I compare 3.33, which one is more closer to the actual value? This is more closer to the actual value comparatively, and this will be much more closer to the actual value. So more the number of digits after decimal, more the closer value to the actual value. So when we don't want to lose the values, we prefer something like double instead of float. But both of them are very slow in calculations. Processor, remember, is always going to take time to perform floating point operations when the time is little more when compared to the basic types, the integral types. These are faster. These are little slow. That's why they introduced one more data type, which is fixed point data type. The number of digits after decimal is fixed. It's always 28. It never changes. And because it is 28 fixed, just imagine 3 point, I can type 28 times 333. So can I say decimal gives the most accurate value? But the side effect of it is 16 bytes. Though in today's date, memory doesn't really matter a lot because we have memory very cheaply available, whether it is in the form of RAM or whether it is in the form of physical storage. In both the cases, memory is cheap, but it does not mean we simply take everything to be of type double. No, that's decimal. No, there has to be a proper balance. Some places you have to choose decimal, some places you'll have to choose double, and some places you may probably not even go for either of these and simply be happy with integral types. So the choice of data type is very, very, very important. They are different. They are different in size. They are different in format. They are different in performance. How the processor is going to execute will take different amount of time for each one of them. Then we have got character data type. Unusual case, character is 2 bytes. Mostly character we know is 1 byte. In C, if I talk about one character, it's actually 0 to 255 will be the range. Why? Because it is 1 byte. One character in C is 1 byte. So the range is going to be between 0 and 255. That means what? Maximum we can have 255 characters representation. Remember, computer cannot store A. Computer doesn't understand A. Don't expect A to be stored on the hard disk. We cannot expect A to be stored on the hard disk. A is not punched on the hard disk. A, B, C, D, these are all characters. So we cannot expect these characters to be punched on the. So what is stored? The binary value of A will be stored, which is nothing but for A it is 65. Generally we call these as ASCII values. ASCII value is a number equivalent of every character. So whenever you have a text editor, something like let us say MS Word, it is not storing just E. It is also storing along with E what is the font which was used for E, whether it is bold, italic, underline, color, background color. Lot of additional information will be stored here along with the text. Whereas in Notepad, it's simple formatting. It will only store the number for every character. That's it. So we know that, or rather we should know that A to Z I'll anyhow come back to it, but just for reference now, A to Z uppercase is 65 to 90. Remember that. Small capital A is 65, B will be 66, go on, Z will be 90. Likewise, small a is 97, small z is 122. Number 0 is different from character 0. I repeat, number 0 is different from character 0. Character 0 equivalent number is 48, and of course 9 then would become 57. So every character has a ASCII value, and when we say ASCII value, it is 1 byte, and the 1 byte limitation is it can support only few languages. For example, if I take English, we have got 26 uppercase characters, 26 lowercase characters, 0 to 9, and then few more characters on the keyboard. If you look at @ symbol, hash symbol, dollar symbol, percentage symbol, and so on. Overall, we say 101 keys keyboard. So let us say approximately 100 characters in English language. Like that, you can take another 100 in Hindi, another 100 in Telugu. Like that, there are so many characters in Chinese, Japanese. How are each character going to differentiate? No, it cannot. 1 byte character set is not sufficient for writing programs which support multiple languages. So what do? There is another character set which is introduced, referred as Unicode character set. It's a 2 byte character set, and this 2 byte character set is going to be used by different languages to represent their character with different numbers. All major languages in the world. I'm not talking about some tribal language where we have 15 people in the world in that tribal community. No. All major languages in the world, English, Hindi, Tamil, Telugu, Malayalam, Oriya, Spanish, Japanese, French, German, Russian, all major languages in the world. Their characters can be represented pretty well with 2 byte character set. That's how this character set was introduced. So Unicode is a standard character set for representing each character of different language mapping to a corresponding number. Like A in Unicode also is 65 only. But A in Hindi or Telugu, A will be having a different number. So every character in Unicode, which is a wider character set, a 2 byte character set, has a representation in the corresponding language in the form of number, one number. So what is the benefit of dealing with character 2 bytes? Multilingual. We can have more than one language support. So today, to write applications which support multiple languages, which is need of the hour. We want people to use our application in China also. We want them to be used in Germany also, where English is not predominantly used. I want those people also to use my application. So my application has to be supporting multiple language character set. And beautiful thing is, language itself has the support here because character is 2 bytes. So the effort of developer goes down drastically. Thinking of writing multilingual application in C, C++ where character is 1 byte is really a big job, very big job. Here language has the support. That's why we say language is simple. Likewise, we have got string. String is nothing but a collection of arrays. Collection or array of characters, we can say. String is collection or array of character. So one important point to be noted, I have put here star, but rest of them don't have star. The basic difference is those which are star are referred as reference type, those without star are referred as value type. Now, what is the actual difference between these value type and reference type? We will see little later. But for reference type, we never mention size. String, object, we don't mention size because their size is not fixed. It depends on the data. And there are a lot of other things which we have to discuss about value types and reference type. It's a big topic. But for all others, there is a type, there is a size which is fixed. Boolean is another important data type which is having only 2 values, true and false. Remember, in C language there is nothing like Boolean. We have always used number only as Boolean. We said 0 is false and a non-zero value, maybe 1, maybe 100, maybe -1, maybe -100, whatever, non-zero value is true. That is how whole thing was represented. 0 is false, non-zero is true. But here, Boolean by itself is data type. It's an independent data type. 1 byte is good enough for representing Boolean true or false. Only 2 values. that variable which is of type boolean will have only two values, either this or that. But at the same time, remember, it is not 1 bit. 1 bit is actually enough, right? 1 can be internally treated as true, 0 can be treated as false, but no. C# does not have support for less than 1 byte data type. Minimum is 1 byte. C# doesn't provide you ability to work on bits. It will always work on a byte, minimum a byte, or a multiplier of a byte. C language gives you that facility. And that's why C language in many cases is referred as middle level language rather than high level language. C# is a modern object oriented high level language. It doesn't allow you to work on bits. It doesn't make your code complicated. So this is all about data types what we have in C#. But this is only introduction to data type. What is most important is how are we actually going to use these data types. So this is how we declare a variable, and every variable is supposed to have name and type. Remember two things. Variables are supposed to be declared, variables are supposed to be initialized, and variables are supposed to be used in an expression. Rather, three. Variables are declared, initialized, and used in expression. These are the three things we do. So I declare a variable, integer n. I want to initialize a value. Go ahead. This is initialization. I want to increment the value. This is expression. Variables are declared, initialized, and used in an expression. That's how we call this thing. Can I declare and initialize in same line? Yes, we can do that. I have declared and I have also initialized to value 0 there itself. Now, what is important in C# language is, if a variable is declared and if it is not initialized, it is going to be a compilation error. You see this red color mark? It's an error. Use of unassigned local variable. If a local variable is not initialized and used in an expression, remember it is a compilation error. Why we should initialize this? It's a rule. Why it is a rule? That fellow who wrote the language knows, I also will not know. So just follow, that's all. I will initialize it. Then this will work. I can now print the value of n. Perfect. Let's take this example where I have integer n1 and I have n2, two variables declared now. Right now, for both n1 and n2, I'll give some value. I'll then declare n3 and I'll say n3 is nothing but n1 by n2. And I want to now print the value of n3 on the screen. n1, n2, 5, 2, divide, and we want to print n3. And we are going to get here 2. Now, simply change this to double. And here itself will declare n3. Why separately? Not necessary. So we don't redeclare it. Not allowed. Now run again. 2.5. What did I change? I only changed from just the data type is changed. By only changing the data type, we are getting different result. Now, what if n1, n2 are integer and n3 is float? Point is, n1 by n2 will be still integer, which will be assigned to float n3. That means the result is still going to be 2 only, because the result of this expression is 2. 5 by 2 is 2. It's not because this is n3 automatically this will be computed, because this is float, this will be automatically computed as float. No, it's not because of that. expressions are evaluated and then assigned to left hand side. So result will be still float on 2 only, even if n3 is of type float. For today, this is good enough. So we have majorly focused upon what is data type, how to deal with data types, casting rules, and everything we are going to see in subsequent sessions. Thank you.